To produce building components in house factories, a wide range of products and materials is required, including wood, boards, technical equipment, and final finishing. Therefore, before production begins, it is essential to ensure that all necessary materials are delivered. To store these materials and products, hereafter we will simply call them materials. For them, corresponding warehouses have been built near the production areas, where the products are protected from the weather-related damage. In general, materials can be categorized into two groups: stock materials and project-based materials. Stock materials are those needed continuously to maintain the production process. These include structural wood, plaster and wood-based boards, insulation materials, electrical cables, nails, screws, and other essentials. Stock materials are reordered automatically when inventory reaches a critical level. Project-specific materials are ordered in precise quantities based on the requirements of a particular project. These include opening fillings like doors, windows, and shutters, as well as customer-agreed finishing materials, technical equipment, furniture, and structural elements such as metal reinforcements and engineered wood stiffeners. Warehouses are sectioned according to the groups of materials and products to be stored. This means that goods of the same type are usually stored in a specific place designated for this purpose. This organization provides a clear overview of all products and materials, reducing the time spent searching for items needed in the production process. The production process must be efficient, meaning that the entire production cycle must flow quickly and smoothly from start to finish. Each factory has developed its own specific logic for how materials and assembled components move precisely. However, the general principle is similar. Production begins with the preparation of the materials needed to make the elements. According to the project documentation, the wood for the frame, boards, and insulation are cut to the prescribed size. By using cut-to-size materials, the assembly of elements on the assembly table is therefore quick and smooth. An automatic, computer-controlled machine tool, also called a CNC machine, is often used to pre-cut wood. A CNC machine tool also enables the production of complex parts with high precision and repeatability. A program corresponding to the drawing created by the designer is entered into the machine tool, then wood material are provided from which the necessary detail is cut out. In larger factories, the lines consist of several working areas following each other, where the corresponding work operations are performed. If, for example, the framework of an element is assembled, it is moved to the next work section, where subsequent work operations are performed. In the case of robotic lines, many work operations are so automated that human assistance is minimal. However, it is not possible to automate everything, and depending on the type of line, the human role remains to a greater or lesser extent. The advantage of robotic lines compared to manual lines is greater speed and accuracy. If communications, such as electric cables, water pipes, etc., are to be installed in the elements, these work operations are usually done manually. In many factories, windows for the outer walls are also installed on the work tables, which also requires craftsmanship. In house factories that produce volumetric elements, separate production areas, or dedicated production halls, are established for these volumetric elements, in addition to the production area designated for planar elements. Compilation of the volumetric element begins with the erection. This takes place in the corresponding erection area, where the floor panel, wall panels, and ceiling panel are assembled. After the panels are assembled together, they form one complete volumetric element. In larger house factories, dedicated movement paths are established for the complete assembly and finishing of volumetric elements. The production logic is similar to that of the automotive industry, where the assembled product moves along a line and scheduled work operations are carried out at specific stations. This method is efficient because workers remain stationary and the materials they need are stored in appropriate areas next to the line. After the volumetric element is erected, necessary work is performed both inside and outside the volumetric element. The goal is to complete as much work as possible under factory conditions, leaving only those tasks that cannot be done in the factory or are not practical. This approach significantly enhances factory efficiency. Typically, all internal building services, such as electrical cables and panels, heating, water and sewage pipes, and ventilation system components, are installed in the factory. Interior work includes finishing in both dry and wet areas, installing door and window openings, and partially fitting furniture. Exterior work involves adding outer layers to wall elements and finishing around openings. Once interior and exterior work is complete, the volumetric element is wrapped in weatherproof film and stored in a warehouse. The entire factory production process is subject to constant quality control, which ensures high quality of the work performed. In smaller house factories, there are no long automatic lines, or there are semi-automatic lines on which different elements are made. Many work operations are performed with hand tools in smaller productions, and if volumetric elements are produced, they are located in fixed place. In such factories, there is more human movement as workers performing different operations move to various modules. Additionally, materials required for the work must be transported to different locations. Although such movements decrease the factory's efficiency, the overall construction process is significantly more rational compared to building structures entirely on site.